The Miracle on the Hudson. Calm under pressure. Shortly after takeoff, a flock of birds struck both engines and created intense psychological pressure for everyone aboard Flight 1549. The passengers felt fear as the aircraft suddenly lost power over New York City. Captain Sullenberger maintained emotional control and calmly considered the few landing options available. His composed behavior helped the crew prepare the cabin for an emergency landing on the Hudson River. After the aircraft touched the water safely and rescue boats arrived, the passengers experienced enormous relief. The survival of all 155 people demonstrated psychological resilience, professional discipline, and effective teamwork. John Nash. A Mind in Recovery. In the late 1950s, the brilliant mathematician John Nash developed schizophrenia, and his academic career was suddenly interrupted. During severe episodes, delusions made it difficult for him to separate imagined ideas from reality. These psychiatric symptoms disrupted his work, relationships, and everyday life. After periods of hospitalization, he slowly began to question the beliefs created by his illness. Over many years, Nash experienced a gradual recovery and returned to the Princeton mathematics community. In 1994, he received the Nobel Prize in Economic Sciences for his earlier work in game theory, bringing greater public attention to mental health. Michael Phelps. Strong enough to ask for help. Even after winning many Olympic medals, Michael Phelps struggled with severe depression when the excitement of competition ended. In 2014, he decided to seek help and entered a treatment program. After the program, he continued meeting with a therapist and became more open about emotions he had once hidden. Through therapy, Phelps learned healthier ways to understand his feelings and cope with pressure. He returned at the 2016 Rio Olympics and won 6 more medals while continuing his long process of recovery. After retiring, he became a mental health advocate and encouraged others not to be afraid of asking for help. Apollo 13. Thinking Their Way Home. On April 13, 1970, the Apollo 13 crew heard a loud bang and soon recognized that their spacecraft was losing oxygen. At Mission Control, engineers used careful reasoning to evaluate the remaining oxygen, water, electrical power, and time. NASA made the crucial decision to cancel the moon landing and use the lunar module as a lifeboat. The astronauts and controllers then had to calculate a safe route around the moon and back toward Earth. When carbon dioxide began to rise, the ground team designed an improvised solution using materials already aboard the spacecraft. Their disciplined problem-solving brought all 3 astronauts safely home and turned a disaster into a successful failure. Alexander Fleming. The Mold That Changed Medicine. In 1928, Alexander Fleming returned to his laboratory and noticed mold growing in a dish of bacteria. His careful observation revealed a clear area where the bacteria around the mold had stopped growing. Fleming recognized that this unusual contamination might be scientifically important, so he did not throw the dish away. He examined the mold and found that it produced a substance capable of stopping certain bacteria. Fleming reached the conclusion that the substance might help fight infections, and he named it penicillin. Years later, Howard Florey and Ernst Chain helped turn Fleming's discovery into a life-saving medicine, and the 3 shared the 1945 Nobel Prize. Helen Keller. The Word That Opened a World. In 1887, 7-year-old Helen Keller was learning hand signs from Anne Sullivan, but she did not yet know that each sign named something. At the family water pump, the cool stream flowing over one hand captured Helen's attention. as and repeatedly spelled water into Helen's other hand. The girl formed an association between the sign and the sensation. Suddenly, Helen understood that the movements in her hand represented the substance flowing over her fingers. She eagerly touched the ground and other objects, placing each new name into her memory. By the end of the day, Helen had learned about 30 words and begun a lifelong journey toward language and knowledge. The invisible gorilla. Looking without seeing. In 1999, Daniel Simons and Christopher Chabris conducted an experiment using a video of two teams passing basketballs. The participants directed their attention toward counting the passes made by one of the teams. While everyone maintained this intense focus, a person wearing a gorilla suit walked through the scene and beat their chest. Surprisingly, many participants did not notice the gorilla, even though it appeared clearly on the screen. When they watched the video again, their perception changed, and the gorilla suddenly seemed impossible to miss. The study demonstrated inattentional blindness, showing that focused attention can greatly limit our awareness of unexpected events. Challenger. When warnings were overlooked. On the night before Challenger's launch, several engineers gave a serious warning that the unusually cold weather could affect the rocket booster seals. Their evidence from earlier flights suggested that the rubber O-rings might not work properly at such a low temperature. At the same time, schedule pressure surrounded the discussions because the mission had already experienced several delays. Despite the unresolved concerns, the final decision was made to approve the launch on January 28, 1986. The consequence was catastrophic. Challenger broke apart 73 seconds after liftoff, and all 7 crew members were lost. The Rogers Commission later concluded that flawed communication and management judgment had allowed critical safety concerns to remain outside the final review process. Phineas Gage. The injury that changed brain science. On September 13, 1848, railroad foreman Phineas Gage was preparing explosives for a rail cut in Vermont when an accident occurred. The blast sent a 13-pound tamping iron through his skull, causing a severe brain injury. Remarkably, Gage survived, although the iron damaged part of his left frontal lobe and many connected pathways. His doctor and people who knew him later reported noticeable changes in his behavior and self-control. The case offered early evidence that the brain's frontal regions contribute to personality, planning, and social judgment. Gage eventually became a landmark figure in neuroscience, although some popular accounts exaggerated the course of his later life. Phineas Gage and the Changed Mind. In 1848, railway foreman Phineas Gage suffered a severe brain injury when an iron rod passed through his frontal lobe. Although he survived and retained many cognitive abilities, people around him reported noticeable changes in his behavior. The trauma appeared to affect his judgment and self-control more than his movement or memory. His altered personality led physicians to examine how different brain regions influence human behavior. Later researchers warned that some accounts of his psychological changes may have been exaggerated. Even so, Gage's case became an important example in neuroscience of the connection between the brain, cognition, and behavior. Pavlov's dogs. Learning through signals. During the 1890s, Russian physiologist Ivan Pavlov studied digestion and the role of the nervous system in dogs. He observed that a dog's salivation response sometimes began before the food actually reached its mouth. To investigate, Pavlov repeatedly presented a neutral stimulus, such as the ticking of a metronome, before giving the dog food. After enough repetitions, the sound alone could produce the automatic reflex of salivation. This process of conditioning showed how learning can connect an environmental signal with a bodily reaction. Pavlov's experiments influenced psychology and neuroscience by demonstrating how experience can establish a temporary neural pathway between events. Cathy Hutchinson and the brain-controlled arm. In a 2012 BrainGate trial, Cathy Hutchinson, who had paralysis after a brainstem stroke, tested a new neurotechnology. A small sensor in her motor cortex recorded neural activity while she imagined moving her arm. Computer software decoded these signals and converted them into commands for a robotic arm. Using thought alone, Hutchinson guided the arm to grasp a bottle of coffee and bring it to her mouth. The achievement showed that a cognitive intention could be transformed into a useful physical action. The event became a landmark in neuroscience and offered new hope to people with paralysis.